morning and welcome here at Techorama to this first session in this Web and UI track. My name is Stropek and I'm looking forward to spend the next 60 minutes together with you talking about some pieces of technology and about the project that was part of my professional life for the last few years. In the last few years, I worked together with a customer of ours and we were modernizing a production plant visualization system. And we used modern web technologies for that, in particular, Angular, SVG, and WebSockets. And I thought the learnings from this project would be a good session to share the information and the learnings that we had in this project and to demonstrate some of the technologies to you that we used here and how we combined them. I'm pretty sure that many of you know Angular. Maybe you know a little bit of SVG. You have seen this nice little graphics and logos on the web. But how can you combine them? And how can you use them in a larger scale project in a kind of manufacturing visualization IoT context? This will be the content of the next 60 minutes. I will show you a lot of samples. I will not write a lot of code, but we will take a look at a lot of code. Simplified code. It would be way too complex to show you the real code of the project. So what I did is I took the core ideas, the architectural ideas and the core technological ideas and simplified them a lot. So we will do some code walkthroughs, and in order for you to be able to recap what I tell you here, I put everything on GitHub. Here is the short link. Just go to this link. This will lead you to my GitHub repository, and you will see the Angular project. I updated it last night to the latest version of Angular, so it's really up to date. And you will also see a kind of roadmap, something like this, or a storyboard that I will use throughout this session. And last but not least, I record this session. So if the technology works out, I will put the recording of this session on my YouTube channel. So if you want to recap what I'm going to show you here, just go to my YouTube channel. You will find it by Googling my name on YouTube. And yeah, you can review the session there. Let's start by introducing the project. I did the project together with a Swiss company that is called Ammann. They are mainly producing and mainly known for producing asphalt plant systems. So they create big manufacturing plants for asphalt, which is used for building streets. And what you see here is a video of a prototype that is currently made. So on the right lower side down here, you see the old C++ based visualization. Don't get me wrong, it is a very nice piece of software. Let me roll the video for you to get an idea. It is a nice piece of software. It has been created many years ago, and it works pretty nice. You see here you have some silos, and you have some weighting devices, and you have some logistical devices that transport some of the material from one silo to the other silo. And all what you see here is really a C++ based visualization with a C++ based real-time backend. This has been in production for many years, and Ammann is very successful with this product. What you see on the other hand here on the left-hand side, this is the new visualization. This is the project I'm going to talk to you about. This visualization has been redesigned from scratch. So Ammann invested quite a lot of time to create a new design language and implement this design language. And now this is no longer a C++ based visualization. But what you see here on the left-hand side is based on Angular, SVG, and WebSockets. I will show you a little bit more about the technology in a few moments. Let me quickly walk you through. If I scroll in here a little bit, you see it a little bit better. You see the mixer receiving some data. This is not just a visualization and a prototype. This is real code. This is Angular and SVG controlled by a real-time C++ backend sent or communicating with the backend using a WebSockets layer. And now, of course, we have some advantages because now we don't need a full desktop anymore. This visualization just needs a browser. Let me rerun the video again for you. This visualization just needs a browser, so it gives Ammann a much larger degree of freedom where they can visualize these things, where they can control it. It's not just a one-way street. This is also controlling the devices on the manufacturing plant. So messages are also flying back from the Angular client into the C++ real-time controller of the machines that are running in these asphalt plants. I'm not an expert in manufacturing. I'm a software expert, so I can't tell you all the details in the C++ stuff. Today, we are focusing on the visualization part. So now you have seen what we talked about. Let's take a look at the architectural stuff. Let's go to the next slide. How does this all work? How do these components work together? The first thing, what we came up with is, you can imagine, there is quite a lot of data transferred from the client to the server and back. And of course, we wanted to have an integrated development experience where we have strong data types. So what we did is or Ammann in that case, the Ammann team, wrote a piece of software that is using a C++ lexer and parser component, reading the C++ structures and translating them into TypeScript interfaces. Okay? So this was not done manually because we are talking about hundreds and hundreds and hundreds of these message types. And all these message types, they have a rather complex structure. And therefore, we want to have type safety. And this has been done, or is continuously done, by translating in the build pipeline the C++ structures into TypeScript DTS files, just interfaces, types. The next thing is, the Ammann team has created a WebSockets server written in C++ that is communicating with the real-time part of the controller and taking the controller messages and translating them into WebSocket messages. The important thing is that the TypeScript interfaces are now describing these messages. They give the WebSocket layer the type safetiness that we need for robust programming on the client side. Now let's talk about the client. The client has been written in Angular. I think we started in Angular 4 or something like this. Now we are, of course, at Angular 7. And we are using reactive extensions, RxJS, the native mechanism of Angular for asynchronous message processing, to receive the WebSocket messages and turn them into RxJS subjects. So we have a kind of message bus. The messages are floating through the Angular application using RxJS pipelines. So whenever the backend sends a message from the real-time controller through WebSockets, we receive them in Angular services. I will show you a simplified demo later on, and put them into RxJS subjects. The RxJS subjects do a kind of multicast, so the subjects send these messages inside the visualization layer to all the different visualization components, and these components then react accordingly. So they change the SVG using data binding and so on, and I will also show you how this is done technologically wise. Of course, you can remember, or you can expect that production plant isn't a standardized project, a component of the shelf product like a phone, for instance. Every production plant is different. Customers can configure it, can tailor it to their specific needs. Therefore, configuration is a very important thing here. For this project, we have, of course, taken the existing configuration databases, primarily XML files, databases, and so on. So we take the existing assets on the backend, and we have written in ASP.NET Core a backend RESTful web API that cares for the configuration data. So if the Angular services need to find out, okay, how many silos do I have, how does the material flows look like, and so on, it reads from the backend using a RESTful web API some configuration data using this ASP.NET Core stuff. This is again encapsulated into Angular services, and of course we use the powerful Angular dependency injection system to make this all configurable. So every production plant looks a little bit different. Finally, we have the Angular UI component library. If you remember what you just saw, you saw the mixer and the silos and many different visualization components. And here comes a very important part into play from Angular. Angular is a UI component library. It's not just componentizing your TypeScript code. You can really build reusable components. And the beautiful thing is that Angular plays very nicely together with SVG. So you can build graphical user interface components that you can reuse and rearrange depending on your configuration data. So what we essentially did is we wrote this component library. We, as the core developers of the team, most parts were written by Angular. I was part of the architectural team, and I had the honor to write some of the visualization components that you just saw. But the important thing is that it is really a reusable visualization framework that we created here. So the engineering people, the people at Ammann who really understand how you care for asphalt and concrete and things like that, they have people who are expert in this domain, but who can also write, to a certain degree, code. In the past, these engineers who are responsible for implementation projects of Ammann asphalt mixing plants at customers, in the past they had to write C++. They learned C++. So what Ammann did is they retrained their engineers and did a training. So today they know how to write TypeScript. They use the visualization library and the existing building blocks to write customer-specific extension because, as I said, every production plant looks a little bit different. So the engineers now it's easier for them because they no longer need to write unmanaged code. They can write TypeScript code and use the powerful mechanism of Angular to tailor the visualization to the customer's needs. To a large degree, it's just arranging existing visualization components, but to a certain degree, it's also customizing them. Maybe deriving them, creating a specialty because this silo has for this customer a specific heating component that should be visualized in this and that way, or there are some sensors with some alarming mechanisms which are specific to this implementation of the production plant, and this is done by the engineering team. So we have a core team who creates the majority of the visualization components, and then we have the engineering team who arranges that, who are responsible for doing the configuration work, and who tailor some of the visualization components to their specific needs. So this is essentially, from a very high abstraction point, the architecture of the system. I will not go into the details of the concrete Ammann project from now on. I will switch gears and go into source code and show you the different technologies, as I said, in a very simplified way, because the project would be too complex to show you all the code. So therefore, I want to ask you whether there are already some questions about the project before I switch to code. Anybody? Question about the project? Okay, so we can go into the code. By the way, Ammann always looks for talented engineers. I had to promise them that I would mention that. So if you're looking for a job and you think Switzerland is nice, give them a call. Good. Oh, no, I switched to code. Question and answer comes later. Good. Let's go into the code, and I have created the Angular project in Visual Studio Code here, and I have my small checklist here. The first thing that I would like to spend a few minutes on is SVG. I'm pretty sure that everybody in this conference, I mean, you are software professionals, knows what SVG is in general. Let me quickly open up an HTML file here. Most of you might know SVG from things like that. You just take an image tag and you add some SVG files. An SVG file in the user interface can then look something like this. I took the Techorama robot and the logo, and it's exactly like that on their website. This is what most developers think of SVG. It's just the vector graphics for doing some logo stuff. But if you take a closer look, let's take a look at the robot here, then you will see that this is just XML. Probably most of you know that too. It's just XML, looks very similar to HTML. So what can we do with it if we combine HTML and SVG? Now, what we can do, and many web developers are not fully aware of that, at least this is my experience, that you can mix and match SVG and HTML into a single code base. That's absolutely no problem. So you can build small visualization components in SVG and embed them directly into HTML. If you know Angular, then you know that the power of Angular comes from things like data binding and componentization and so on. And if you can mix HTML and SVG, can we also bring in Angular and do some dynamic stuff using data bindings and control animations, using TypeScript code, which we can easily then unit test and things like that? And the answer is yes. That's the power of what I would like to show you. How can you combine the beauty of Angular with the power of SVG? Another thing that I would like to point out here, which is maybe not completely obvious, but it's important, you can style SVG with the same CSS that you use to style your HTML code. So this is important. Let me show you what I mean here. This is a very simple example. Let me zoom in a little bit here. You see this is the red and this is semi-transparent, and if I open the CSS to the right side here, then you see that here this rectangle is styled using a CSS, and you can use all the nice things from Angular like style encapsulation that you might know. If you have a component and you define a style, then this style is only applied to the component and not to the entire application. This is important if you build an application in a larger team, because the CSS styles should not interfere with each other, and this is true for CSS and CSS styles too. So this is an important one because, as you know, maybe I will show you if you don't know that, Angular can do pretty impressive things when it comes to CSS. You can do class bindings, style bindings, and so on, and I will show you how this is done and how you can combine it with WebSockets and so on. Good. The next thing that you can do, and I just want to make sure that everybody is on the same page, we'll go into Angular in 5 minutes or so, is transformations. You don't need to calculate coordinates over and over again. You can simply translate SVG elements by moving them, by rotating them. Well, you can apply any kind of matrix transformations, and this is important. If you have, for instance, animations where things are rotating and things like that, then these transformations become pretty powerful. And the beautiful thing here is you don't need to do some coding in TypeScript where you calculate some paths of the animation. Everything is done using SVG and SVG transforms. And browsers like the Google Chrome, they are pretty powerful in applying these transformations. They are fast. Even if you combine animations with transformations, they can display the visualization at a very high frame per second rate. Next one. You can do pretty powerful drawing, which might not be completely obvious if you are not used to SVG. Take a look at that one, for instance. These are two rectangles which overlap each other. But in this case, I decided to do a little bit of a background pattern. Think of an IoT scenario where you want to do some hatching, which visualizes some maybe content of a silo, and maybe you want to animate the hatching to visualize that material is flowing from this to that and so on. And the SVG is pretty powerful when it comes to calculating those fill patterns. Because take a look here, I used a fill pattern consisting of circles here, but these are two different rectangles. They are not filled independently, but the fill pattern is calculated in a combination of the rectangles. And if you build more complex shapes where you want to do some, as I said, hatching or visualize some IoT, maybe alerts using some fill patterns, then this comes in very handy because you don't need to write a lot of code. The only thing that you have to do is you have to ask your designer to come up with a fill pattern. They will probably use their design tools, and then you just apply the fill using such a URL syntax. And again, you can control that by using CSS classes. So if you want to visualize, I will show that later, in Angular, an alert in a silo and visualize the alert by an animated hatch fill, for instance, you just set a CSS class and the rest is done by SVG. That is the point that I want to make here. In general, animations are a pretty powerful thing. Before I go into animations, let me show you another guy here, which is very important when it comes to SVG, and I just want to make sure that everybody is aware of that. In SVG, you have a powerful mechanism which is called a path. A path consists of points, and these points can be connected in various ways. It can be lines, vertical, horizontal lines. It can be Bezier curves. It can be arcs. It can be parts of circles and things like that. And essentially what you do is you define a drawing cursor, move the drawing cursor, draw some curves, for instance, and somewhere in there you will also find lines, H like horizontal lines, V like vertical lines, and essentially what you do here, you are generating a path, and then you can use this path in various ways. At the end, you have this Z, this closes a path, and you can also create multiple shapes in a single path and draw them accordingly. The important thing is that these numbers here, they can be data bound, and I will show you that later on. So you can use Typescript to do some calculations, come up with the points, data bind them into paths, and then use Angular logic to algorithmically draw some shapes that you use for visualizing some IoT stuff. That's the point here. You don't need to write the code yourself. You just come up with the, of course you have to calculate the points. I mean, this is your domain logic, but the rest is done automatically by SVG. You can then use things like groupings, where you take multiple of these paths and translate them as a group. And then you can bring in the last element of this demo. Let me open that one. And that is animations. If you take a closer look here, then I called this the car animation. See that one? And the car animation here on the right-hand side is a path, and it's using a keyframe animation, and it's a very simple way of doing an animation that changes the translation, so it's moving the car within 3 seconds, for instance. Let me show you the result. If I reload that, you will see that the car is moving. Here it is. And this can be a very simple mechanism to, for instance, visualize that some materials is transported using a transport cart from one silo to the other silo. Only a few lines of code, and you have a powerful animation system that can be, yeah, pretty interesting in terms of IoT. Last but not least, and my experience from many different customer projects is that the last one is the thing that is mostly unknown to many web developers. It's the concept of so-called stroked lines. And this is important when it comes to IoT. Let me zoom in a little bit and scroll down here. Take a look at these lines here. Oh, let me do a live zoom here so you will see the result. You see just a line, green line, that's okay. Then you see a dashed line. Then you see different dashed lines. You see an animated dashed line that could be, for instance, used for visualizing an active material flow when material is flowing from one silo to the other. And down in the bottom, you see some kind of bullet chart that visualizes that a certain threshold has been exceeded. How can you do that? How is that done with SVG? In a very, very simple way. Let me show you that. Well, the first one, we'll take a look at that line. It's trivial, it's just a line, nothing special. The second one is important. See that stroke array 5,5? That means that we want to have 5 pixels filled, 5 pixels non-filled, 5 pixels filled, 5 pixels non-filled. Very trivial. The next thing is interesting because we just add a CSS class here. So let me show you the CSS class. It's the same as before. It's just an animation with keyframes where I'm animating to the so-called dash offset. That means that the dashing is now moved. I have 5 pixels filled, 5 pixels unfilled, and then I'm moving the thing by 10 pixels, and I do that indefinitely. And the result is this kind of ant effect where you have the line running, visualizing some animation, some, for instance, material flow. Take a look at the lines of code. Just a very simple CSS class, and at the end of the day, you just add it to your line here, and that's done. And I will show you in a few seconds. You can use regular Angular class binding to bind the class to a Typescript flag, for instance, that visualizes whether material is currently flowing or not. If you remove the class, material stops flowing. If you add the class, material starts flowing, and you don't need to write any code for that. The next thing that I would like to show you are these two lines. Please take a look at this visualization. It's the bottom two lines here. They are the same code, but this one visualizes a value of 75, and this one visualizes a value of 125, and the threshold where the value turns from OK to critical is 100. That is the idea here. How can we do that? Of course, we can start to calculate write some fancy TypeScript codes to calculate some coordinates. We could do that, but we don't need to do that in CSS. One important design goal of the Ammann team was that the designers, the ones who draw the SVG, are the ones who are in control of the UI. The developers should just provide the values and the rest should be done just by SVG. The designers should not have to write some TypeScript code. Another goal was that the SVG code that is used in a visualization is as far as possible exactly the SVG code that the designers created in their domain SVG and with their SVG tools. So what we do here is, take a look at these lines, we combine this bullet chart from two lines, but the only thing that's really different is the value here. You see here 75 and 125. Everything else is absolutely identical. And the trick is this dash offset. You see it here? So what I essentially do here is I tell the system I have, in this case, a value of 100. This is the first line. It is green. And then I have a value of 1000. This value isn't really relevant. It's just a very, very high value which is not visible anymore. It's far to the right. We don't see it. The important thing is that we have the alarm here and we use the dash offset. So we are shifting the line a little bit to the right, and therefore it is only visible if the value exceeds the threshold of 100, and therefore we have some static lines which can be controlled or which become a bullet chart just by controlling one value. The point here, what I would like to make, is that SVG is much more powerful than most people think. And you have to think a little bit how you can cleverly use the possibilities of SVG to make your visualization or the development of your visualization more productive. Of course, you can apply the same concept of dashed offsets, for instance, in any other shapes. For instance, in this case, we have a very simple visualization, a kind of gauge, and this is exactly the same. The only thing is this is not a line, but this is an arc. The concept applies equally. The important why I point out the arc is that here calculating the coordinates manually in TypeScript would be complex. You need angle functions, sinus, cosinus, and things like that, and calculate all the coordinates. I simply don't do that. I just draw two static arcs and control the length of the arcs by using dashed arrays and dash offsets. Okay? So, on a meta level, I wanted to show you that SVG knows more and is capable of doing more than you might think. Okay? You don't need a visualization framework or buy powerful chart components to do those simple things. They are just built into SVG. Good. Now let's take a look how we can use that in Angular. And last but not least, we have 30 minutes left. The last 10 minutes, we will take a look how we can control this using WebSockets, for instance. The first thing that I would like to show you is an example which now uses Angular. Let's go here into the data binding example. You see the bullet chart here, and if I increase the value, it turns red, and if I do it like this, it goes down. So how is that done? Let's take a look at the code here. This is the code that you see here, and the point that I want to make is that one here. You will see that it looks like regular data binding, nothing special here. But the point is, we have this attribute binding syntax. And this is an important point that you have to understand. I don't know, how many of you would say you have solid Angular know-how? Just that I know who is... Okay, some of you, but not all. I would say half of the group. Okay, for those of you who don't know Angular that well, Angular is a compiler-based language. So what Angular does, it's taking these templates using an Angular compiler, which is, by the way, currently rewritten, Project Ivy, if you read about it. And this compiler turns the HTML templates into JavaScript. So at the end of the day, the browser doesn't get any HTML anymore. The browser just gets JavaScript. So essentially, you could say in Angular, you don't write HTML. You write the Angular template language. And then this Angular template language is translated into JavaScript ahead of time or just in time. You can choose that. You can control that when building the application. And at the end of the time, you're just executing JavaScript. That's the logic of Angular. This is how Angular really works. And therefore, if we don't have HTML, we can't use HTML attributes in Angular. We always use DOM properties because we are using JavaScript. We can only manipulate DOM properties and not HTML attributes. There is no HTML in Angular. Okay? So therefore, it isn't obvious that SVG works because SVG is just HTML attributes. There is no DOM property about SVG. And this is the reason why we need those attribute bindings here. Those attribute bindings tell Angular, hey Angular, in this case, x2 is not a DOM property. It's an HTML attribute, and you have to use a different JavaScript. You have the compiler has to generate a different JavaScript in order to interact correctly with SVG and do the data binding. The next point that I would like to make here is the only thing that is calculating or that is controlling the visualization is this data binding here. As you probably know, Angular supports calling functions in data bindings. That's absolutely no problem. So what we have here is a little bit of TypeScript code. Let's take a look into the TypeScript code. Here it is. This is the logic that does some calculation. You can imagine that in your IoT scenario, you are calculating some coordinates or turning one unit of measure into another unit of measure. This is the business logic that you write in TypeScript. And this TypeScript code can very nicely be unit tested because you don't need to do DOM testing or end-to-end testing to test your business logic. And in HTML, if we take a look, we can simply do data binding with SVG using the business logic written in TypeScript tested by unit tests. Okay? Good. This is the attribute binding. What about events? The nice thing with Angular is that you have these event bindings. And event bindings in Angular work exactly with SVG as you would expect it. Let me show you what I did here. I created a switch. You see that one? If I click on the switch, something is changing here. And of course, it's also touch enabled. I just used my finger to switch the toggle here. And the only thing that I had to write is, see that one? On a group, not on a single element, on the entire group is an event handler. So SVG is pretty powerful even if you have complex groups consisting of multiple shapes like paths that you can remember the mixer and so on. It had some controls and buttons on it where the mix master can take a look and control the mixing process, turn on the heat or do things like that. Everything can be controlled with the finger by just applying Angular event bindings on SVG groups, and it just works. That's the nice thing here. So if we take a look at the business logic, again, it's very, very simple. The only thing that we do here is manipulate TypeScript properties, and the rest is done by data binding of Angular. So this shows a little bit about how SVG and Angular works together in terms of data binding, how you can isolate your business logic in Angular components and therefore do powerful unit testing. Of course, this is not enough. This was just the basics. Now let's shift gears and go one step further. The next demo that I would like to show you here is that one, SVG Components. So let me reroute the page and maybe go to mobile view, and you see the idea here. Let me turn it like that. It's just it's just arbitrary data. I'm just generating some random data, and you see we have a budget value and we have a cost value, and then we have a bullet chart here on the right-hand side. How can you componentize the bullet chart into reusable visualization components? That's the point that I would like to show you here. So let me show you that here. First, of course, you can use Angular modules to build visualization libraries. Angular has its own module system. For those of you who are not that familiar with Angular, it's really a module system which sits on top of ECMAScript modules, so it is much more powerful. And maybe if you are not fully up to date with Angular, in the latest versions of Angular, it's also very simple to create reusable libraries. So what you can essentially do, you have this core team who is creating a library of reusable visualization components based on SVG and Angular, and they can pack it into an NPM package, and then you can take this NPM package, put it on a feed, and let the engineers take the feed, consume it, and build IoT visualizations from it. And this is exactly what the Ammann team has built. Now let's take a look at one of these components. Here it is. This is the budget chart component, and let's first take a look at a wrong implementation. This implementation does not work. It's a regular Angular component, as you would expect it. To make it more easier for you to follow along, I added the HTML template directly into the Angular component code. Typically, you separate that. You have a view file and you have a logic file, but to make it easier, I show it to you here. It's very simple. You have a selector and you have some input bindings. Works perfectly fine. All the things that you know in Angular, where you have inputs and outputs, and you take the output of one component and somehow connect it to the input of the other components, that works perfectly fine. That's just Angular, nothing special here. But this one has two important things. The first one is here. This is important. Now, before, we didn't have to write this SVG prefix here. Why? Because Angular was pretty smart. If we take a look at the original thing that I showed you, this one, we just had SVG here, and down there, we didn't need to write SVG : because this is a child element of SVG, and the Angular compiler recognizes that it has the SVG parent here. However, in our visualization component, there is no parent SVG element. Therefore, Angular doesn't know, is this an Angular component line? Is this a web component line? Or is this the SVG HTML element line? And if you have something like that, you have to use the prefix here that you see here. Now, let's check that. Let's go into my project list and break our visualization, just to make sure that we understand why this is important here. Let's do that one, and let's put that into a comment and reload our application, and it will break. Hopefully, it will break. Yes, it broke, just as expected. If I go here and zoom in a little bit, maybe here and here, you will see that we still have our SVG lines, but they are no longer visualized. Why? If we use a regular component in Angular, you will see that the Angular component is injected into the DOM below the SVG element. For HTML5, that's perfectly fine. What does the browser do if it comes up, if it sees an element that it doesn't know? It ignores it. I don't know it, I don't care, I just continue. SVG is different. SVG does not allow custom elements. If it sees an element that it doesn't know, it stops. Therefore, we have a problem. Luckily, we can fix that easily in Angular. So, what I have here is the fixed version of our budget chart. And the small but important difference here is that we are now using an attribute directive. So we are using these two brackets here, and they indicate that this thing is no longer a new element, but it's an attribute directive. And the big difference, I can show you that here, is that originally in the broken one, we have used the component like this. Now we are using an empty group. This group is empty. It doesn't contain any content, but we apply an attribute directive to the SVG group. And then the content of the visualization element gets injected into the group. And this is exactly what we want to do. With that, we can apply transformation to the whole thing, we can apply CSSs to the whole thing, and that's exactly what we want to have. This is why this works pretty nicely. So turn it into an attribute directive, and then you can build componentized larger SVG elements. I often get asked the question, hey Rainer, why should we? Why don't we make every element on the screen a separate SVG drawing? You could do that. It's a question of performance, and sometimes you want to componentize it on a very granular level, and then you would probably make the browser a bit unhappy if you have thousands and thousands of separate SVG elements on your screen. With that, you have one SVG drawing, a larger one, consisting of just a few lines and rectangles. The browser is fine with that, and the rest is done by Angular. So with that, we have a reusable component that is very easy to use, and even the engineering team who is building customer-specific visualization can easily handle this code because they have a nice little intranet site where they have a documentation, and it's easy to use. Just add a G here and do something like this, and the rest is just data binding, as you can see it here, with a max value and a width and some things that come from the backend. It's very easy to use. Nice programming model. This was important. Maybe I would like to recap that. Always keep in mind that the scope of this project was that not only a hardcore black belt Angular developer should be able to build a visualization, but we had the hardcore black belt developers building the UI components, but then we have the Angular, the engineers who know Angular and who know TypeScript, but they are not that deep. They are, at the end of the day, their primary domain is engineering and not software development. So the programming model is very important to make it easy to use and to raise developer productivity from an engineering perspective. Good. Next one. The next demo that I would like to show you is another thing where we use animation now in real world. Let me zoom in a little bit. Oh, I have to go from here. Oops, that's a little bit too large. Let's do it like that. That's good. I think then you can see what I mean. What I did here is I added a context menu, right-click. It's pretty large, sorry, but I think I want you to see it. And I click on it, and you see, I will do it again, and you see it's animated, very simple. How can you do that? Well, this silo, granted, it's a rather simple visualization, but I think you get the point. It isn't that trivial because it has some shapes which have to move and so on. Well, it isn't that trivial, but at the end of the day, the code isn't very complex. Let me take a look. Here is the silo component, exactly. This is the silo component, and this is the TypeScript code. Good, good. Now the HTML is pretty simple. If we take a look, it consists of some SVG groups, and you see I'm using, where is it, a regular context menu. I didn't have to implement the context menu in SVG. I just took an open source context menu Angular component, and it just works with SVG. That's the nice thing. You just specify that you would like to have a context menu on an SVG group element, and it just works. So you can combine DOM-based Angular components that you maybe buy from a third-party component vendor or get from GitHub, open source libraries and that on, and you combine it with SVG. The important thing is that you see here that we have some states that are combined with Angular animations. This is the concept of Angular animations. With Angular animations, you can control animations in your Angular TypeScript code, and you don't need to go back to CSS animations. Of course, CSS animations are in the background, of course, but this is way more powerful because these animations are, at the end of the day, controlled by your TypeScript business logic. Let me show you what I mean here. You see here, I have an opening state. This is the business logic of this component. I call it, it's a lookless component. The business logic just has a property, a state, opening state, and has a method toggle flap, which changes from open to close and close to open. That's the only business logic that we have here. We don't calculate any other things here. No coordinates, nothing like that. Very easy to unit test, important for me. The animation itself is pretty simple because I just came up with a bunch of translations. This can be created by people who really focus on user experience design. They take the tools that they love, maybe some Adobe tools, they design the animations, they create videos, go to the users. This happened for Angular. They went to the users with videos discussing the user experience, the design language, and once they knew the parameters, how large should these things be, how fast should they be, they came to the developers, or in this case, the designers know how to write SVG. They created some SVG, CSS animations, and we turned them into Angular animations. And at the end of the day, the only thing that you have to do is, again, in this case, in the context menu, some event binding that calls the TypeScript business logic. So on a meta level, on a higher abstraction level, what were the design goals here? Have the designers who know how to use SVG and who are skilled in user experience design stay in their domain and let them have a language that they understand, love, and that they have the right tools for, SVG. Let the business logic guys who really want to focus on logic. I mean, you can imagine that in the Ammann project, the business logic to convert some numbers or unit of measures, it's not that trivial. They should use their tools. TypeScript. They should use unit tests in order to test this stuff. And then the combination is done by Angular, and you have the SVG and the DOM-based components with it. Of course, we also do DOM testing, not just unit testing the TypeScript code, and this also works pretty nicely. If you are deeper into Angular, you can not only test the TypeScript code, but you can do DOM tests, so you can verify that the SVG was manipulated accordingly if some event happened without having to write end-to-end test. That was a very important thing because we needed a high level of maturity in terms of testing. Any questions so far concerning this sample? This is an important one because it combines DOM, SVG, TypeScript. Good? Nice. So for the last few minutes that we have, I would like to go into the last topic, the WebSockets topic here. For this demo, I've written a dummy backend. This is my dummy backend. It's not very complicated. I wanted to keep it very simple. I'm just using WebSockets, plain WebSockets, not Socket.io or Signal.R or things like that, nothing fancy, just to show you the concept of WebSockets. For Angular, for Ammann, we are really using WebSockets purely, not a fancy library on top of it. So the WebSocket client here just goes through all clients and sends some data. And this data is just random data, nothing special. But the point is that I sketched here the concept of type safetiness. In the project of Ammann, we would get these interfaces that you see here by cross-compiling the C++ structures into TypeScript interfaces. As you can see, these interface systems, they can be derived. So it's a complex object-oriented hierarchy of message types where, for instance, just for this very simple sketch, we have a base interface which just contains a message type. In this case, just a number, it could be an enumeration, whatever you want. And then we have a specific message which has, as you can see it here, a target. Because the C++, the C++ controller in the background, whenever it sends messages, this message is targeted to a specific device. It could be a flap on the bottom of a silo, it could be a waiting device, whatever. The device ID is a very important piece of data. It's the address, the target of the message. On the other side, if the visualization, can you remember the toggle that I showed you? Sends back some data to the back end. Again, we need some address information in order to know which flap should we open. And this is exactly this hierarchy of interfaces. There are hundreds and hundreds of these interfaces, and as I told you, they are auto-generated. But this is important that we have this type safetiness. Here in this dummy client, I'm just creating very simple messages. They all have type 1 because I didn't want to come with hundreds of message types. That's not necessary to bring the point across. I have one device ID, and then I just take the random value. That's all we do, and then we broadcast the value to all clients, because in this case, we only have one. Good. So let's take a look in the visualization. I created this backend service for you, and as you can see it here, in the client, we also have the same interfaces. So the backend, in the case of Ammann C++, in our case Node.js here, share the same data structures as the client does. In the Ammann version, C++ structures, TypeScript interfaces. Here are the TypeScript interfaces on the client side. A nice thing is that TypeScript can can do some type checking if you want with so-called type guards. Take a look at this function here. This function verifies the message type, and it doesn't return just a Boolean, it returns the fact whether a given object is a specific type. I don't know if everybody of you is so deep into TypeScript, but this is a very important feature of TypeScript for applications like that. Because in TypeScript, you get an anonymous JavaScript object, not like in C# or Java, where you can use reflection to ask the language, is this of type XYZ? That doesn't exist in JavaScript. In JavaScript, we have an anonymous object, and we have to write imperative code to find out whether something is of a specific type. And in this case, we are just finding out whether an incoming message is of type silo fill message. You will see that this matters in a second. Now here, I sketched a very simple backend service. It's a service, it doesn't have any UI here. And this this service uses WebSockets to receive messages from the backend. Whenever we receive a message, we parse the message data, and we use an RxJS subject to publish this data internally. So this is where the multicasting comes in. There is, in our simple case, a single receiver receiving the WebSocket, pushing it into an RxJS subject, and everybody else can now listen on this subject, which is an observable, and react accordingly. Now let's take a look at the consumer. This is the silo component. Here it is. It's just a one-liner. As you can see, in this case, our silo with WebSocket component, it's a specialization of the silo that you have seen before. If you want to dive deeper into the code, take a look at my GitHub repository. Does nothing else than it takes the backend, takes the RxJS subject that you see here, and uses a pipe to transform these things. And the first thing that this thing does, it's filtering, because our silo is only interested in messages which are addressed to it. So in this case, we are filtering on the device ID, and we are using the TypeScript type guard here. And the beauty of this programming model, I will show you that here, is that it is fully type safe. So because of the M here, it's just a message, a generic message. Can you remember what the message was? Just this one. It only contains a message type, nothing else. So it's just a message. If I write m dot, the only thing that I get is the message type, because I don't know the type yet. But if you use a TypeScript type guard is silo fill message, then TypeScript gets back a Boolean indicator whether the message is a silo fill message. And with that, the rest of the expression, the type changes, because after the type guard, it is no longer a generic message, it's now a silo message. And this is exactly what we want, because now, again, I can write a dot here with the M, but now I'm behind the type guard, and now the interface gives me the information that, oh, now I know it's a silo fill message, so I can give you a device ID and a value. I get type safetiness with anonymous JavaScript objects and interfaces. And please keep in mind the integrated view where we cross-compiled from C++ down to TypeScript to get type safetiness without having to write additional code. If they change the C++ backend and introduce new message types, The build process will regenerate the TypeScript interfaces. The TypeScript interfaces will be built into the Angular client, and the engineers immediately get type safetiness and all the goodness of Angular and TypeScript. That's the idea here. And yeah, the rest is simple. We just assign the value to a property, and this property, as you've seen before, drives data binding and visualizes the filling of the silo. And the result will be something like this. Let me quickly show you that. Silo with WebSockets. And you see, this is WebSockets flying in. I can take a look at the network here. Let's see, where do I have the WebSocket? And if I go to here and go to messages, you will see on the right-hand side the WebSocket messages flying in. Somewhere to the right, we should here we should see the data. So let's go here, and there you see the values coming in. Yeah, and this is what drives my silo. So this was the point that I wanted to bring across. By doing this integration, using WebSockets as a communication protocol, using TypeScript for type safetiness, using RxJS as a kind of internal message broker, if you want, some kind of message bus on the visualization, combine that with the UI component library that I can easily create with modern versions of Angular and the goodness of SVG, it was, for us, a very good architecture to come up with this modernized version of this production plant management system. Because it was easy to use, we had high developer productivity, we could write, we could achieve a high level of testability, we have a high test coverage in this project, and we can really focus on different developer roles. UI experts, focusing on SVG, domain software development experts writing the UI component library, and engineers who also have a programming model that they can master to build customer-specific visualizations based on this framework. So this was what I wanted to show you. We started slow with a little bit of SVG, and I hope even if you are experienced web developers, that you recognized or that you learned some tricks in SVG that you didn't know before. And maybe I hope that I could connect some dots between the technologies that I used and inspire you for your next IoT visualization project. I would like to thank you for coming. You have the link at the beginning of my slides. Take a look at the code. I'm also available on LinkedIn, Zing, Facebook, Twitter, and so on. So if you have any questions or if you want to keep in touch, just connect with me, and yeah, maybe we'll see at the next Techorama. Thank you very much for coming. If you have any questions, come up to the front here. I'm more than happy to answer them. Thank you very much. Enjoy the rest of the Techorama.